happen. So does anybody have any questions for me about class in general, about Canvas, about what to turn in, anything like that? Any questions, comments, concerns? Okay. At any time, if you guys have anything or you need me to stop, remember, just let me know, raise your hand, and we'll go from there, okay? So yesterday we talked about tectonic plates, and then we talked about what the tectonic plates are, but I actually want to go back a hot second to that tectonic plate page because I want to ask you another question, okay? So when all of this plate motion is happening, okay, down here at the bottom of yesterday, nope, too far. I got to figure out the lag on the camera. Can everybody hear me okay? And there's not like any distractions or anything? Okay, cool. So when I'm looking at that, we had why would the crust type change the movement of the tectonic plate? And we said that the density of the crust is going to send the denser layer down into the asthenosphere. But what is caused after an earthquake, or after an earthquake happens, like those movements, what is sent outward? Like what happens afterward? What do you feel from an earthquake? Anybody can use press your space bar and answer. What would you feel from an earthquake if an earthquake happened?
The waves of it.
But you wouldn't be able to feel, what would that feel like? Like in California when they have earthquakes, what do you think they feel at home?
Like shaking.
Very good. So they have shaking. So when we talk about, I'm going to go up here to the top of my page. When we talk about plate boundaries, which are all of these black lines on our picture, okay, those are going to be where earthquakes happen. Which means it's going to produce vibrations. Okay? Those vibrations are what we're going to talk about today, and those vibrations, like Leah said, are called waves. Specifically, those are called seismic waves. Okay? So, on your Pear Deck, you will be able to see your information for seismic waves. If we go over to this other side, you will be able to fill in those blanks. I'm going to give you a minute or so to fill in those blanks just like I would if we were in class, okay? So, and if anybody needs me to read anything, just let me know.
Miss Kennedy, what if you're already done with it?
Then just hang out and wait until I start again, okay?
Okay.
Nice job. And go ahead and give me a thumbs up whenever you guys are done. You just put it up really quick and then put it down.
Miss Kennedy, did I miss a lot?
No. We have a Pear Deck. So the Pear Deck code is it's right here at the top of my notebook. UCZQT. And what they're doing is they are filling in the blanks of their notebook using the Pear Deck like we would in class. So if you want to do that, that's really all extra we've done. All right, so I'm going to read through the notes, and then I want you to fill in the blanks as we go. So if you just hit your space bar, or if you want to, I'm going to unmute you all, I think. Let's see. I'm going to unmute all of you. Okay, so as I get to the blank, please answer. Okay, so seismic waves are vibrations produced by
Earthquakes. Seismic waves.
Very good. They're produced by earthquakes. They travel at different through the Very good. So we now know that seismic waves are vibrations produced by those earthquakes. Those earthquakes, remember, are going to come from the movement of those tectonic plates. As they move, they can move towards each other, they can move side by side, and they can move away from each other. All of those different movements are going to cause earthquakes. Those earthquakes from the different locations, like this one here in the picture, is very specific. And all of those waves are going to travel outward, okay? This allows us to figure out, when they travel throughout the earth, what's inside of the earth, okay? So let's go from here. It says the speed depends on
distance,
density and composition. Very good. I'm just looking at the Pear Deck. Density and composition. All right, remember, density, where are you going to find the densest materials? On the outside or the inside of the earth?
Inside.
Inside of the earth, very good. Oh my gosh, look at that word. That says composite. Composition. Yay, Mrs. Kennedy. Okay. So, based on the density and the composition, here's how we are going to be able to tell the difference. What blank the seismic waves travel blank in solids? Faster. Very good. I was trying my absolute best not to give you the answer on that one, so I'm very proud of myself. I'm going to try this again. Seismic waves travel blank in liquids. Very good. Okay. I almost think about when you have a solid, all of those molecules are closer together. And I always think about, have you ever gone to like run towards the water? If you've ever been to a beach, and as you get more and more in water, it like slows down and like you can't move anymore. So think of like the way you change, or if you get into mud, your ability to travel a certain speed changes when that density and composition changes. So the same thing happens with the Earth. So scientists can now see that when I'm looking at my diagram in the top right, when scientists are looking at the earthquake, every time a seismic wave leaves the earthquake spot, it's going to be picked up around the around the Earth by what's called a seismograph, okay? And all of these locations, scientists are going to find, they're going to measure and record the earthquakes, okay? But notice, those earthquakes are not going to reach every single part of the Earth, okay? So, how are they measured? Seismographs measure the blank at which, what's that blank? Seismographs measure the time, thank you, at which the different waves arrive. Very good. How many of you have family members or friends who always arrive on time? Okay. Now, how many of you have family members that always arrive early? And how many of you have family members or friends that arrive late all the time? You can always, you guys totally sold them out. Okay, so the same way that you can expect those specific relatives and family members and friends to show up on time, early, first, second, third. I think even one time we were like, bet this person's going to come first at Thanksgiving, and then this one, and then this one. And we like watched them all trickle in. And it was hysterical because we could know. So the same way that scientists have been able to figure out the characteristics of seismic waves, they can figure out what the inside of the Earth looks like based on the arrival time at the different locations in the Earth. Okay? So, right here it says measurements calculate the, what's our first blank? Density. And thickness of each layer. Okay? And again, it's because if it starts to slow down, okay, if we look at the top part of our notebook page, if the seismic wave starts to slow down, we know it's traveling through what? Liquids. If the seismic wave is going faster, we know it's going to be in solids. Okay? And then how long it takes to travel through that layer would determine its thickness with the speed and so on and so forth. Okay? You are not going to need to know, like, you will not have to draw this diagram. Okay? You do not need to know how to draw that. Okay? So what we're going to learn in our next section is the seismic wave properties, and we're going to learn all about the different types of seismic waves. Okay? So what I have figured for, I'm going to leave this up if anybody needs to continue to